Good morning, or good afternoon, depending on when you're seeing this video. We're going to talk about angles and angle addition. So this should be pretty straightforward. It's almost like the segment addition that we did, except now it's actually going to be doing angles. So this talks about array. We've already talked about array. Remember, arrays can only be named one way. So ST here is the only way you can name this ray. These are what you call opposite rays. Remember, it shares a common endpoint, which in this case is letter A. So these are opposite rays because they're pointing in opposite directions, and they both start at letter A if we talk about ray AR or ray AY. This is what an angle looks like. This is called a side. This is also called a side, and this right here would be considered the angle. This right here where it bends, or I guess could technically kind of break in half-ish, is called the vertex. Okay. Different types of angles. We have an acute angle. An acute angle is between 0 degrees and 90 degrees. So anything in between there would be called an acute angle. It's your small one. Then you have something called a right angle. A right angle is perfectly 90 degrees. Perfectly 90 degrees, and it has a little box down here to tell you that it's a 90-degree angle. And then you have an obtuse angle. Obtuse angles are greater than 90 degrees, but they're less than 180 degrees. So anything that looks like this would be considered an obtuse angle. What is a straight angle? Well, a straight angle is just a straight line. Just a straight line, that's all it is. Straight angle, straight line. And those equal 180 degrees. Okay? In order to know if something is congruent, whenever we're talking about angles, you have to look at their little tick marks. So if I have two tick marks, and this guy has two tick marks, then these two guys are one and the same. They are congruent. Okay? So that means if this guy was 50 degrees, then this guy would be 50 degrees. And if this guy is 50 degrees, this guy is still 50 degrees. Same thing down here with the ones that are in purple. You have this guy, which has one tick mark, and this guy over here also has a one tick mark. So that means they are congruent. So if this guy is 120 degrees, this guy is 120 degrees. This just talks about naming angles. So you can name angles both ways. So for example, if we're looking right here at this one here, you have this one would be called angle MOP or POM. Again, that's MOP or POM. If there's a number down here, you can also call it angle 4 or whatever angle or whatever numbers down here. You can actually say angle 4. And if it's just a single angle, like just one angle like this guy, how he's just one, because this guy is considered two put together. Okay, this guy is two of them put together. This guy is just one. Okay, if that's the case, you could just name him by his vertex, which is angle O. This guy over here has a bunch of different names for all his angles. This one here that I'm tracing over in red, this red pointer, this one is DUS, or you can name it SUD. So you can go forwards or backwards, okay, just as long as this guy's in the middle. You can also call it angle 5 because angle 5 falls right here in the middle of that, okay. And then you have this angle right here that I'm tracing over in red. You can name it SUT or TUS or just angle 6. Now it's our turn. So let's name this guy. Number 1. It says in each problem, name angle 4 and any other ways possible. Careful, there may be more boxes shown than you need. So for number 1, you can name it FBD, FBD. And you can also go the opposite way, DBF, DBF. So you could say DBF, or you can name it angle 4, angle 4. And then the last one, since it's a single angle, it's not two of them put together, it's just one guy, you can name it by just its vertex, because it's a single guy, okay? So that means you can name him angle B. Number 2, you have angle CGA, CGA. And then you have angle AGC, so you can go backwards, AGC. You can name it AGE, AGE. There's another angle right there, AGE. You can also go backwards and do EGA, EGA, EGA. You could also name this guy right here angle 4. All right, keep moving along. What is an angle bisector? Remember, an angle bisector is where it cuts the angle perfectly in half. Okay, so if this was my original angle, let me see if I could show this for you. Let me draw it in white. So if I was to take away this guy right here, kind of like that. Okay, if I was to take that guy away, and then I was to put this angle back in here, okay, if I gave you this angle and I said this is angle CAM, and I said I want to show you what would, if this guy was 50 degrees total, okay, this guy was 50 degrees total, okay, if he's 50 degrees, well, I guess I should write that down there in the corner. This guy's 50 degrees, okay, and then I said I want you to draw an angle bisector. So you would cut him perfectly in half, okay? So if you were to do that, you would go back to that original picture we had, which looks like this, okay? And so if the big angle was 50 degrees, and I cut 50 degrees perfectly in half, each one of these little angles would be 25 degrees. Hopefully that makes sense, because you cut the number in half. So if it's an angle bisector, look at the big angle, cut it in half, and you're good to go. All right, here's a couple of examples of angle bisectors. Okay, it's telling me that ECG, so ECG over here, ECG is 124 degrees. So total, this guy is 124 degrees. And it tells me that CA is an angle bisector. So that means that it cuts 124 degrees perfectly in half. And if I cut 124 degrees perfectly in half, it gives me 62. So angle 1 and angle 2 would both be 62 degrees. And then you do the same thing down here for FDH. It says that FDH up here in our paragraph, FDH is 78 degrees. So FDH total is 78 degrees. And if BD is an angle bisector, I would take 78 degrees and I would cut it in half. So in your calculator, or if you prefer to do it by hand, you would do 78 divided by 2. And you would get 39 degrees for angle 3 and angle 4. Angle 3, 39 degrees. Angle 4, 39 degrees. What is angle addition? Basically, if you want it in simple terms, is if I give you the if I give you the measure or the degrees of angle 2 and angle 3, you would add them together and you would get the total distance that they would make, which would be DRP. So if I took angle DRI, which is angle 2, if I took this guy, DRI, and I added angle 3 to it, which is considered to be IRP. If I took these two together and I added them together, they would give me the total from DRP, for DRP. Hopefully that makes sense. And we're going to do a couple examples of that. So if we look at this one here, we have angle 1 over here is 58 degrees. And then it says, what is the measure of AEC? So AEC, AEC. In order to find that out, the measure of angle AEC, you would say, okay, AEC would be 35 plus 58. And that would give me my total here. Okay, because we need the total of all of, let me see if I could show this a little bit better. I want all of this in here. I want to know what all of this is put together. Okay, so that would be 35 and 58. Add those two together, you get 93. Hopefully that makes sense. Okay, now let's do another one. It says BED, BED, BED. So it's asking me for all of this in here. That's everything it's asking me for. BED. Okay, so I would take 58 and 51, I'd add them together, and you get 109. 58 plus 51, 109. Hopefully that makes sense. All right, let's do this last one. It says measure of AED. So I want AED. So I want the total AED. I want the big one. So that's AED, and I want everything in between. Okay, so I want all of this. So that means I would take 35 plus 58 plus 51. Type that in your calculator, you get 144. And you just did all those problems. So let me go over that one last time. It wants the measure of angle AED. So everything in here, I got to add up in order to get this total here. Okay, so that's 35 plus 58 plus 51 gives you 144. All right, let's do it again. Measure of angle 1. All right, the measure of angle 1, we have to figure out. In order to do that, we have to make sure that we understand that AEC, so the total distance here, AEC, is 86. So this guy right here has a total. It's telling me the total up here in my paragraph. It's telling me that the total is 56. I'm sorry, 86. I'm sorry, 86. So it's telling me that this total distance here is 86. So I'm going to take away right here what's in hot pink in order to give me what's left so I can find angle 1. Okay, so I'm going to take my 86, which is up here in my story, and I'm going to subtract 54 from it, and it's going to give me my leftover, which is 32. Okay, let's try another one. The measure of BED. So I want BED. So what we're looking at is this total angle right here. So we got BED. So we're looking at this total here, okay? It says, what is that measurement? Well, I know my two measurements. It's 54 and 48. So I add those two together, and it gives me 102. Okay, the next one says, what is the measure of angle AED? AED. So from A to E to D, I would have to take all three of these and add them up. All three. stop this screen. All right, so when we're looking at this angle, AED, all here in blue, we got to add them all up. Remember, angle 1 is 32 degrees, because we already found that out. Angle 1, 32 degrees, 32, plus 54 plus 48. Add all three of those together, it's going to give you this big angle, okay, the big one, which is 134. All right, so here has some actual algebra in it, so this one could be a little bit more difficult. It tells us that AMI, so this angle here, AMI, is 138 degrees. Okay, so that big angle right there is 138 degrees. Okay. So we need to find, it says, find each measure. So number one, what is x? Okay, well, we'll do that one last. AME, well, can we do that one last is the question. All right, no, we have to find x first because we have to find out what this angle is and what this angle is. I know it says 21, but we need to show that. So it says also up here in the paragraph, it says below MA and ME are opposite rays. So MA and ME are opposite rays. So this is a straight line. So that means that that is 180 degrees. Ray MR bisects IME. So whatever this is, okay, whatever that angle is, it's cut in half perfectly right here. Okay, so I'm not worried about all of this stuff over here. I am not worried about any of this. Okay, so imagine if all this over here in blue does not exist. I'm just worrying about what's over here in yellow, right here in yellow. Okay, this is all I'm worried about right now. Okay, so it says if this guy right here is the bisector of this angle, then that means that this guy and this guy are the one and the same thing. If they're one and the same thing, I can set them equal to each other because they're the same thing. I know they don't look like the same, but if this is the angle bisector, then these two things are the same. So what we do is we went over here, we put it all the way over here, so follow me all the way over here. Okay, we put them equal to each other. Subtracted 2x from both sides, you get x minus 3 is equal to 5. And then you add 3 to both sides, you get x is equal to 8. So if x is equal to 8, then we can come over here and plug in 8. So we got 8 times 3. You get 24. And then minus 3 is 21. So this guy's 21 degrees, and if this guy's 21 degrees and these guys are the same, then this guy's also 21 degrees. All right, now it says, what is the measure of angle AME? AME. Well, if they're opposite rays, they're 180 degrees. Okay, because it's a straight line. It makes a straight line, so 180 degrees. That's by definition. Okay, we went over that just a couple minutes ago. What is the measure of angle AMD? AMD. AMD. Okay, well, you're going to take 138 degrees. So this guy right here, what's in blue, okay, what's in blue, because we're trying to find AMD. So look at something that you do know, which is the total distance from here, all in blue, okay. Remember, they told you that's 138 degrees. And we're going to take away what's in hot pink. We're going to take away this guy right here. Take him away. Take him out of it, okay. Take that slice of pizza out of there. Okay, if you take that slice of pizza out of there, what are you left with? You're left with 36. 138 minus this big slice of pizza, which is 130 or 102 degrees, equals 36 degrees left. Okay, so this right here in blue is 36 degrees. Now it says find the measure of DMR. DMR. Okay, DMR. Well, I know what DMI is. I know what this guy is right here in pink. He's 121. Or I'm sorry, 102. 102. DMI is 102. Right here in pink, purple, whatever you want to call this, it's 102. But we need DMR. So we need to add this guy right here to 121. So we got 121, or not 120. I keep saying 121. I'm sorry. It's 102. 102 plus 21 gives me 123. So this guy total here, this little slice of yellow, okay, plus this purple gives me 123. All right, let's keep moving on. I'm going to leave the video right here, and I'm going to let you guys try to practice this part, okay? And then I'll post this as notes to Google Classroom for you so you can check your answer on here. So this will be like some extra practice for you, okay? So I'll leave it right here for a second so you can pause the video and watch it, or pause it and practice this on your own. Okay, now I'm going to go to the next slide. And then one more for the answers. So if you don't get one of these numbers, you did something wrong. Okay, I hope you enjoyed this. I hope you learned something here. Again, remember, if you ever have any questions, please don't hesitate and make sure you reach out and ask. I'll be more than happy to help you out.